Hey Math 20-1 students, we're going to look at lesson 3.1, completing the square. So we're going to be comparing vertex form to standard form, and our goal is to be able to go from standard form to vertex form. So when you're looking at standard form, there's only so much it tells you. Standard form only really tells you the y-intercept just by looking at it, versus the vertex form gives you a lot of information because it tells you the vertex, and that helps you find your axis of symmetry, your max or min value. So there's a lot more information I find that's helpful with that. So we want to go from standard form to vertex form. That is our goal for the lesson. Previously, if you look above, in example number 2 from 3.2, lesson 3.2, we went from vertex form in this one to standard form. So that's a way easier procedure. So here, there's a lot of steps you'll notice, but it becomes repetitive. So once you do a few and you practice and you get it, you can try some homework questions. If you understand it, you don't have to continue on. I just have a lot of examples, hoping that that will help you. Okay, so I want to show you a perfect square trinomial, and I want you guys to see what is the pattern that I'm doing to get that. So for this one, if I have x squared plus 3x, we know that the factor that would be the same that would give us for it to be a perfect square trinomial would have to be x plus something times x plus something. Well, the two numbers would have to add up to the middle, and they have to be the same, so 3 and 3 would be the only numbers that would add up to 6. That would be identical. And then if you multiply these numbers, that always gives us our constant in standard form. The next one, we have x plus something times x plus something. The two numbers have to add up to 7. Well, the only way that's possible is to take 7 and divide it by 2, and you should find that that's 3.5. Well, 3.5 and 3.5, to get that constant, we would have to always multiply them because that's in FOIL, our last terms together. So 3.5 times 3.5 gives me 12.25. Our next example would have to be x plus something and x plus something, that if you add up these numbers, it gives us 2. Well, 1 plus 1. And if you multiply them, you also get 1. And then 4 and 4 is how we get this number. So a trick is that if you divide this number by 2, you're going to get that number you need in that bracket. And then if you square that number, that's going to give you the constant, which is 16. So that's what we need to remember. The pattern is that we take half the constant, or half the b value, because when we're talking about standard form, it's always called ax squared plus bx plus c. Our b value is the middle term. We're taking half that value and then we're squaring it. Square it. So, for example, -3, if I took half of -3, I get -1.5. And then if I square that, I should get 2.25. So that's my constant. If I have -6, if I take -6 divided by 2, I get -3. And if I square that, I get +9. Our next example is, what if I have a triangle there? Well, it's the same rules apply. You're going to take half that triangle, which is going to look like a right triangle, and then they just want you to square it. So that's it. Half that triangle, which is like a right triangle, and then squared. Done. So it could be a happy face, it could be any symbol, you're just taking half of it, squaring it. So I'm going to show you a more basic example and show you the steps, the explanation of how to change a standard form function into a vertex form function. So the first steps we would do is, when we're starting with the standard form, we would put brackets around anything that has the variable x. So we are putting brackets or parentheses around, in our case, they're called the ax squared plus bx equation part. Okay, so put brackets around the terms with the variables. Next, we want to figure out how we got these numbers. Well, that's what we did before. To get this 25, you're going to have to take half of 10, which is equal to 5, and then you're going to have to square that number, and that gives me 25. The trick is, though, we have a 25 that we just placed in there, but mathematically we did something that's not right. We put something in that shouldn't be there. So our way of still making this mathematically true is that if we put something in, we have to take it out right away. So we're writing it as 0. So 25 minus 25 is equal to 0. So what I'm doing is I'm adding this number here, but at the same time, I'm subtracting it. So let's write that down. We're going to take half the b value and square it. Then add and subtract that number symbol. Our next step is to take that negative number outside of the bracket. Take the negative outside of the bracket. And then here, this is called factoring, where if you write it out, x plus 5 and x plus 5, that's the same as x plus 5 squared. If you do FOIL, first, outside, inside, last, you're going to notice you get back to what we had originally. So what the trick is, I want to be able to factor it so I get that x minus p squared form. The only way to get that p value is to take, half of that b value. So if I take b divided by 2, that is the same as your p value. And then you just have to put squared outside the bracket, and your q is by combining the negative 25 and the positive 23 together. Okay, so we are factoring and then combining numbers to get Q. Okay, so that's kind of the gist of it. That's what we're going to be trying to do to get from standard form to vertex form. So let's look at example number 1. So this is a word problem where they're not giving us, again, the equation. We're going to have to write this in vertex form eventually, but before I continue, I have to get the equation. Now, this one's a question that comes up very often. This is a revenue question. Revenue is always equal to the cost times the number of items that you sell. I don't need that really. So number of items. So the cost times number of items. So we want to represent the quadratic function that's going to represent this scenario. So revenue, we're going to call it R, is equal to, well, look for any costs. Well, we know we're talking about a water bottle being sold, and we know that originally it was sold for $8. So I'm going to have one bracket that represents the cost, and the other one representing the number of items. So a sporting goods store sells reusable sports water bottles for $8. Put that 8 in the cost bracket. At this price, Their weekly sales are approximately 100 items. Well, we know originally there was 100 items being sold, so that's going to go into your number of items bracket. Research says that for every $2 increase, you're going to go plus 2x. X is going to represent how many increases in price you made. So X represents how many increases in price, and they're saying they're gonna charge you $2 extra for every increase in price that you do. But what can happen is that you're gonna sell 5 fewer water bottles. So you're gonna say subtract 5 fewer water bottles per increases in price. So every time you increase the price, you're going to sell 5 fewer water bottles, and that's what that stands for. Now, to get the quadratic function, I'm going to put this into standard form. So I'm going to do FOIL. 8 times 100 is 800. And then we have our outside terms, minus 40x, plus our middle, which is plus 200x. And then our last terms together would be minus 10x squared. So our revenue equation will be negative 10x squared when you put in standard form, positive 160x plus 800. This is what I'm going to use now in order to make my vertex form equation and to be able to find the maximum, because when you put in vertex form, that makes it easier to find your vertex, and that is going to show you your maximum if it's a downward facing parabola, which in this case, because it's negative 10, it is. So let's start by writing r equals negative 10x squared plus 160x plus 800. Step 1, so this one's going to be slightly trickier when it comes to doing our work. First, we're going to start by putting brackets around our ax squared plus bx form. The next thing we're going to do is we're going to do something slightly different. We have to get rid of our a value, because in vertex form, we always have this ax minus p squared plus q. There should never be anything in front of x, and in this case, we have a negative 10. So we're going to have to divide out this negative 10 in front of x squared to both of those numbers in the brackets. So we're going to have to go revenue equals negative 10. So that's what happens when you're dividing it out. It comes in front. This is called factoring out the greatest common factor. And you're going to be left with x squared. And then in your calculator, you can go positive 160 divided by negative 10. And that should give us negative 16x. Then we're going to leave some space. We still have this plus 800. Now our next step is we're going to have to figure out what half this number is, just like in the previous example, and then we're going to have to square it. So half of negative 16 is negative 8, and then when we square that, we get positive 64. So we're going to have to always add first and then subtract that same number. So we're technically adding in a 0, which doesn't change what the equation actually means. So that's why we do this. Our next step is to remove the negative 64 outside the bracket. But in order to do that, it's affected by the negative 10 in front. So it's being affected by this guy right there. So in order to multiply or bring that negative 64 over, we're going to have to multiply it by negative 10. Okay, so we're going to have revenue equals negative 10. We're going to have x squared minus 16x plus 64. But outside the bracket, we're going to have to multiply the negative 64 and the negative 10 to get positive 640. And this positive 800 is still adding to it. So there's still 800 still there. It doesn't disappear. Our next step is now to start getting into vertex form. So this is where we have to factor it and write it as x something p squared. So it could be x plus p or x minus p squared. And then plus q, we're going to have to get that from adding these together. This is our q. If you add them together, you should have gotten 1440. So a trick to getting our p-values, it's always going to be half this number, half. Our p is going to be half of negative 16, which is negative 8. So that's what we'll put right there. And there is our vertex form. Now, the reason I like this and the reason this is an important form is now I can write the vertex. The vertex is 8, positive 8, because you always use the opposite sign that you see for your p-value, and then positive 1440. This is always your maximum value. So it does ask us, determine the maximum value revenue the manager can expect based on these estimates. What selling price will give you the maximum revenue? So we know that the maximum revenue is equal to 1440. The next thing we have to do is we have to find out the cost. What is the selling price of this water bottle? Well, we can't just use this 8. The 8 is not the answer, but we can use it to get our answer. So remember, cost is equal to our bracket of 8 plus 2x. So in order to actually solve for the cost of the water bottle, we're going to have to go 8 plus 2 times the x coordinate of the vertex. So we're going to have to go 8 plus 16, and that's actually $24. So we know that when the cost of the water bottle is $24, that's when he's going to make a max revenue of $14.40. So by changing it into vertex form, we are able to pull out the P and Q and then use that P value to solve for the cost of the water bottle and use the Q as our max revenue. So verify our solution. We can always graph this and see if this works. So we can graph it and check the vertex. So we can always check to see if the vertex is 8 and 1440. If it is, then that would be our way of checking to see if it's true. Now, an assumption we're making is we're taking it to the real world and we're saying, well, is this always going to be true? Well, no, because there's so many factors here. The factors are economy. You know, if everybody starts if everybody starts using plastic water bottles again, they're not going to start buying reusable water sports bottles anymore for $24. So that could be just a trend, right? So that would actually change their sales. So these maximum revenues are based on just like the average. Now, if they have a winter season or if it's colder outside, maybe people are not buying water bottles as much, so that could affect it. So economy could affect this, and these are assumptions that we're making, is that this is always going to happen, that the economy is staying the same, that we're not getting these changes, that we're getting the same kinds of customers, same amount of customers each day. So there's a lot of factors here. So that's what you kind of want to think about when they say assumptions. The next example number 2, is what if we have fractions? So you'll see a bunch of those in the homework. Make sure you practice them. Those are really good ones too. If you can do fraction ones, you can do any kind of ones. So step 1, put brackets around your ax squared and your bx form. Then we always want to divide your first 2 terms by 2. So I'm going to show you how to work with fractions. So that 2 would go in front. Now 2 divided by 2, you don't have to write 1, so it's going to be x squared. But at the side, I'm going to take negative 5 over 6, and I'm going to divide it by 2. The reason being is I have to actually go negative 5 over 6, and whenever I divide by 2, I'm actually going to multiply by the reciprocal of that number. So even if you don't see it, there's a 1 underneath of a whole number. So when you flip it, it becomes 1 over 2. So when we multiply, we always multiply the tops together. So it'll be negative 5 times 1, which is negative 5. And 6 times 2, we multiply the bottoms together to get 12. So that is our new bx value that we need to include. So we're going to write negative 5 over 12x. We're going to leave a bunch of space here, and then we're going to put this plus 1. The next thing we do with this number is we always have to take half of this number, meaning we have to divide it by 2 again, and then we have to square it. Okay, this is our procedure whenever we're trying to go to vertex form. Okay, so again, we're going to repeat what we just did. We're going to multiply by the reciprocal of 2, which is 1 over 2. We're going to get the answer, which is negative 5 over 24. And then we're going to square that answer, which means that you square the top and bottom separately, and you should get 25 over 576. So that is what I'm going to add and subtract. Okay, our next step is always to remove this negative value, but we're going to have to multiply it by 2, right? So we're going to have to go y equals 2 x squared minus 5 over 12x plus 25 over 576. And then over here at the side, I'm going to do the negative 25 over 576. We're going to multiply that by 2. And that's like saying 2 over 1. So when we multiply 2 over 1 by that number, we get negative 50 at the top, and the bottom 576 times 1 is going to stay the same. So that is what we are putting outside the bracket now. Negative 50 over 576, and we're adding 1 to that. Now, in order to put these two guys together, these guys, we're going to have to get common denominators. So whenever you add and subtract fractions, you need common denominators. So 1 is the same as multiplying the top and bottom by 576 by 576. So we're going to multiply the top 1 by 576 and the bottom 1 by 576. And that's how we get that. Now, when we add and subtract, we only work with the tops and we keep the denominator the same. So negative 50 plus 576 in my calculator would equal positive 263 at the top. At the bottom, 576 and 576, you keep the common denominator. Oh, actually, it should be a little bit more. Give me one sec. Let me check my calculator because that's already simplified. So negative 50 plus 576 equals positive 526 over 576. And then to simplify that, we can divide the top number by 2 and the bottom number by 2. And this becomes 263 over 288. So that's the simplified form of this. So we're going to replace that soon. We also want to factor this. A trick is you're always going to have this x value, and then you're going to have that minus p value. Now, it's always going to be half this number, remember? Because if we take half this number, that's how we get it. And it's always if you square it, you'll get the last number. So the trick is if you take half of negative 5 over 12, which we already did way here, over here, we can use this answer, and that's our p, Negative 5 over 24 is our p-value. So we did the work, so we don't have to repeat it. So we're going to put negative 5 over 24. So our final answer that they were looking for is, you're going to have your a value as 2. X minus 5 over 24 squared, that's your p. And your q value is 263 over 288. So this is a standard of excellence question. So these are like the level 4 questions. This is where you want to get to. You want to be very comfortable with fractions to be able to work with like all the numbers being fractions. So try those in your homework, and that can really tell you if you're how confident you are, or if you know what you should know going forward. Okay, so those are little things that I want to advise you on, is practice with fractions. Get comfortable with fractions. And then these are more simpler ones. So I'm going to whip through these just to give you some more practice. But what you should be doing is stopping the video and trying these different leveled ones to see if you're getting and you're able to do these on your own. Okay, so from now on, you should be stopping these, trying all the rest of the examples on your own, and confirming your answer. Okay, so pause the video. Okay, so you should have now filled in all your answers. I'm going to give you my answer so that way you can check your answers. So step 1, remember, you put brackets around your first two terms. You take half the middle and you square it, and that's what you're adding and subtracting. So half of 8 is 4, and if you square it, you get positive 16 minus 16. And we still have this minus 7 sitting outside there that we don't touch. And then we have x plus half of this number will always be your p-value. So you can do that right away and save yourself a lot of time. It's always going to be your x minus p-value squared. In this case, your p-value is negative, which is why we have a positive there. And then we need to bring this number out, but since there's nothing in front for a, we just have to bring it out and not have to worry about multiplying it with anything. So those are the easiest cases. That leaves us with y equals x plus 4 squared, and then minus 23 when we combine the values of negative 16 and negative 7 for q. So our vertex, what's important is to write it out as negative 4 and negative 23. So practice writing out that vertex. Make sure you don't miss out on questions like that. Next one, put brackets around your x values. Factor out the value in front of x squared always. So that's going to be dividing out a 2 from both of them. So that's going to leave you with x squared minus 10x. We're going to leave space because we're going to have to take half of this and square it. So half of it is negative 5, and if we square it, we're going to have positive 25 minus 25. There's no q value right now. There's no value outside, so we don't have to worry about joining it with something else. 2x squared. So here we have 2. The a value is going to stay the same, but now remember we can take half of that negative 10, and that's going to be our p. So we can save ourselves a lot of time by just taking half of negative 10, which is negative 5, and then that's your p. You have to square it. This number comes outside by multiplying with a 2 because there's an a value. So if there's ever an a, you need to multiply with the number coming out. So that's going to be negative 50 that's removed. And there is your vertex form. The vertex of this is 5 and negative 50, just for practice. B, brackets around your x's. Divide both of them by 3. Y equals 3 in front of x squared plus 10x. Take half that number, square it. We're going to have 5 squared is 25, subtract 25, and we still have that positive 41 outside. You're going to remove this number by multiplying it by 3. You're going to have y equals 3. X plus half this number right here is 5, and that's your p squared. And when you move the negative 25 times 3 outside, you get negative 75 plus 41. y is equal to 3x plus 5 squared, and it's minus 34. So your vertex is, guys, -5 and -34. Level 3 questions. Now we have this negative sign that we have to be careful about. So again, for both of them, we're going to put brackets around our x values. We're going to divide them both by -3. So we have y equals -3 in front as your a value. Inside, you're going to have x squared minus 18 divided by -3 is -6x. We're going to leave some space, and we're going to subtract 24. This one, we're kind of doing them at the same time. So we're going to have that -3 for the a. X squared. -27 divided by -3 is positive positive 9x. And then we're going to leave some space, plus 13. So we're going to take half that number and square it. So what you want to watch for is you're going to have that here, we're going to have a fraction here. So I'm going to keep the fraction just to prepare you. So in this case, remember, we're taking half of -6 and squaring it. Half of -6 is -3. When you square it, you get positive 9, and then subtract 9 right away. Move that -9 by multiplying with the a value of -3 out. So we have -3x. Half of this number right here is -3. You're going to square it. And then outside we should have positive, because -9 times -3 is a positive number. And that's going to be 27 minus 24. So we have -3 as our a. X minus 3, this is our p, squared, and then put those together, we get positive 3. Our vertex is 3 and 3. Okay, with this one, I'm going to have to go back to that fraction kind of idea. So I'm going to do a little bit of work here. We're going to take half of 9, which is 9 over 2, and then we're going to square it. And that's going to give us 81 over 4. Subtract 81 over 4. So you square the top and the bottom separately, and you just leave it like that if you want to. Then we're going to take out this negative number by multiplying it with -3. So we're going to have x plus, remember, half of this number is now 9 over 2 squared. And then we're going to have to figure out what -81 over 4 is multiplied by -3. So we're going to have to write -81 over 4 multiplied by -3 over 1. In my calculator, I'm going -81 times -3. I get 243 over the, so that's multiplying the tops together. The bottoms together would just be 4. So you're going to get positive 243 over 4. But we still have to add 13 to that. So to add 13 to that, we're going to have to multiply the bottom by 4 and the top by 4, because we need common denominators with the other one that we're going to add it to. So we have y equals -3, x plus 9 over 2 squared, and then 13 times 4 is 52 over 4. So we're going to have to write 243 over 4 plus 52 over 4. Just going to rewrite it. Now, 243, we need to always add the numerators together. So if I add 52 to it, I get positive 295 over the same denominator of 4. And then you can't simplify that any further, so that is perfect. The vertex, guys, is going to be -9 over 2 and 295 over 4. So I am trying to get you guys to get more comfortable with fractions. So work with fractions whenever you can so that you get that comfort level. Our last example, again, I want you to pause if you haven't done this one. Try this one yourself and then check your answer. Press play and you'll see me write my answer. So you want to sketch any relevant parts of the problem on the grid. Well, we know this is the y-intercept. So if we were to graph that, we would plot approximately at 3, we would put a point. Now I'm going to try to find that maximum height because that will give me a lot of information by changing it into vertex form. So just practicing that vertex form, you're going to divide out -4 from both the t values, and that's going to leave me with t squared. In my calculator, I'm going 48 divided by -4, and I get -12 t. Leave some space, plus 3. Now you're going to take half of -12, which is -6, and then you're going to take -6 and square it, and you get positive 36 minus 36. Then what we want to do is bring that negative guy out by multiplying it with -4. So we have now -4 t minus half of this number is -6. That's our p, and then we have a square outside of it. And then -36, we're multiplying it by -4. We get positive 144, which we have to add with 3. Our vertex form is then -4 t minus 6 squared plus 147. So the maximum height reached by the projectile is going to be 147, and it's going to be in meters. Okay, so we verified algebraically. You could always graph it and then go to your graphing calculator and see what the maximum value is to check. The sketch, we know that it's going to occur at the point of 6 and 147. So let's say I have 5 here, 6 would be there, and then we would plot maybe the value of 147. Here's 6. And I'm just going to show where it touches. Okay, so that's my vertex. Use that information to plot that point. So they also want to know the height of the projectile 3 seconds after the launch. Well, we can substitute h of 3. This is just notation. Don't put that into your calculator. Don't use that for calculation. What you do is in your calculator, you put -4 times 3 squared plus 48 times 3 and add 3 to that. So in my actual calculator, you're going to substitute that. So you're going to go to -4 in brackets 3 squared plus 48 times 3, add 3. We get 111. So we know that our height is going to be 111 meters after 3 seconds. How many seconds after launch was the maximum height reached? That was the x-coordinate of your vertex, so you can say at 6 seconds. When t is equal to 6 seconds, that's when it will reach its maximum height. What was the height of the projectile at the launch? This is like another way of saying what is the initial height. That's always the constant in your standard form. So in our case, when our height is equal to 3 meters, that's the initial height that it was launched at. So 3 meters, it comes from looking at the constant of positive 3. Determine when the projectile hit the ground to the nearest tenth of a second. Well, in this case, we can actually use our graphing calculator for that, right? So we would go to our graphing calculator. We would put in this function. We would use that vertex to figure out the window that matches it. So let's go over there and plug this into y equals. So our equation that we're using is -4. Instead of t, we're saying x squared plus 48x plus 3. Go to your window. We know that the x value will be approximately, we know that the halfway point is about 6 approximately, so maybe let's go up to 15 just to be able to see that, just in case. We know that the max value goes up to 147 meters, so let's go to 150 then, just slightly higher so it doesn't cut it off. As you can see, this gives us a really nice parabola shape. We want to find out the x-intercept, meaning where this lands. So we're going to go second trace number 2, which is 0. Move your cursor as close as you can to your x-intercept, and as you move your cursor to the left, you should find that your y is positive. So press enter where y is positive. When y becomes negative, that's when it becomes the right bound. Press enter and enter again for you guys. And it should be at 12.062 seconds. Okay, or you can round it to like 12.1 seconds to the nearest tenth because that's what they want. So you need to round it to 12.1 seconds for it to be fully correct. Okay, so once you're done that, make sure you try some homework questions. I really advise you to go over the, in this case, 3.3, completing the square. I want you guys to make sure you practice ones with fractions, okay? So really challenge yourself to get comfortable with the fractions and then go from there, okay? I hope you